Yeah. So in this session, we will start with the introduction to Wireshark, like the theory of Wireshark and the main purpose of Wireshark. And secondly, how we can get familiar with the interface of Wireshark. Then we will discuss about the capture filters and display filters. Okay. So that is the plan of attack for today. So so can anyone tell me like what is the main purpose of Wireshark? Why do we use Wireshark?
To understand the packet flowing and to capture packets. That's fine.
Yes. Just
Yeah,
give me a second.
to analyze the network where the packets flow, which uh, which packet flow in take a long time, a short time. That is,
Yeah, exactly. So Wireshark is mainly for capturing the packet first. Secondly, it is mainly for analyzing the packets. So that is like the main purpose of Wireshark. So what kind of packets Wireshark can capture? So let's say I have a machine. Okay, let's say I have a Windows or any kind of machine, and I'm capturing on that Windows or that machine. So Wireshark will capture the packets which are coming to and from my interface, like which are going from my machine and coming to my machine. Secondly, Wireshark will capture the multicast and broadcast packet. That is what Wireshark will capture the packets. And it can capture all types of packet like TCP, UDP, HTTP, like all sort of packets, but it will going to capture the packets of your machine, of your interface. And if you wanted to capture the packets of the network, like the entire network, then you can capture on the router. Okay, so the packets which are coming to and from your interface of your router, that you can capture the packets. Okay, but before capturing, you need some permission because Wireshark is a very powerful tool. It can capture any sort of packets. So it can capture the every detail which is in your packet. The we can say it can capture the username, password. If the username, password are in the clear test, so it can capture any kind of packet. So that is why before capturing, we should need the permission for capturing the packets. Okay, because in some countries we have some legal ethical rules what kind of traffic we can capture and what kind of traffic we cannot capture. So Wireshark is an open source, which is what is the meaning of open source? It is available for free. Secondly, we can also contribute in the Wireshark source code. That is why it is open source. And that is I think the main reason Wireshark is very powerful, because we have many developers, they came and they contribute in the Wireshark. So that makes the Wireshark very powerful. So it is open source, which is we can use for free, and the source code of the Wireshark is available, and we can just contribute. Okay. Then Wireshark is cross-platform, which is we can use Wireshark on Windows, on Linux, and on Mac OS. And it is mainly for capturing and analyzing the network traffic. Okay, so it can capture the traffic which is coming to and from your interface, the multicast and the broadcast packets. That it is the most popular tool and used in almost every domain. Like we can use Wireshark in the networking for troubleshooting. We can use Wireshark in the security, like for identifying the malware traffic, for identifying if someone is applying the attack or not, etc. We can also use this Wireshark in the application development. Let's say you are developing any application and you wanted to you wanted to check the protocol which you have implemented on your application. Then in that case, you can also use Wireshark for checking if your application is working fine, the flow of your application, the data flow, like how your protocol is working, etc. So Wireshark can be used in multiple fields, like in the networking, security, and in the application development. So Wireshark, as I said, it is an open source. So the main source code is located on GitLab. So you can visit this URL. Now Wireshark is made up of three languages, C, C++, and Lua. These three languages. Okay, so this is the official source code of Wireshark. Here, if you wanted to contribute, then you can just clone this repository and you can start contributing, like you can add your own features, etc. And before implementing the code, you have to just you have to ask the permission from the community that can I add this feature or not. So it is not, not like compulsory. It is just I'm telling that this is the official source code. Here you can read out the source code. So the language are C, C++, and Lua. These three languages. If you know these three languages, then you can simply check out the source code. Again, it is not compulsory. Then there's another version of Wireshark. Wireshark is a GUI application, which is like graphical user interface. We have another application, like another version of Wireshark, which is the CLI based. That is known as T-Shark. So in the upcoming sessions, we will discuss both Wireshark and T-Shark both. That is the introduction part of Wireshark. Now, how we can download Wireshark? So we can simply, if you are using Windows, then we can simply search for Wireshark download and get download from the official website. So from here, we can click on this 64 installer and you can install Wireshark. Installing Wireshark is very straightforward. Once you download, then click on next to install, and make sure to install all the libraries, or we can say some packages coming with the Wireshark. Install that also, like nmap, WinCap, and T-Shark. So install everything. Just click on next and install. That's it. So this is how you can install it. If you are using Linux operating system, then for the Linux, for the macOS, you can just click on this macOS file. For the Linux, you can, if you are using the Fedora Linux, like Fedora or Red Hat based Linux system, then you can search for the Wireshark in the CLI, yum search Wireshark, and then you can use this command, yum install, and the Wireshark software version. Okay. If you are using Debian, like Kali Linux or ParrotOS or Ubuntu, then you can apply these commands. Basically, in the Debian system, the Wireshark is pre-installed. But if you wanted to install in the Ubuntu, then you can write apd-get install Wireshark. That is like the installation of Wireshark. Okay, now we can discuss the interface of Wireshark. The interface of Wireshark is quite complex. So let's see. So first, when you open the Wireshark, you will see this particular interface. So here, this part, here you will see the list of all the files which you have recently opened. So these are the files which I have recently opened, like this file, this file, and this file. So these are some recent files which I have opened. Then here comes the interface settings. Like these are the interface in my machine, which I can use for capturing. You can have you can have multiple interfaces or you can have one interface. It depends on machine to machine. So these are my interfaces in my machine. And here comes the capture filter. Here you can apply the capture filter. Now, what is capture filter? We will discuss later. But for now, here you can apply the filter. And here, these are the details of your interface. Okay. So this is the Wireshark main window. Here you can use some help here. Like you can visit the Wireshark website. And here comes the Wireshark version here. And here you can visit the user guide, Wikipedia of Wireshark, question answers, mailing list, and etc. Okay. So here I have this interface. Now I can start capturing. So this is my interface. And here you can see these lines. These lines are saying that there's some traffic going on in these interfaces. So I have traffic in this interface, and in this interface. So I have traffic in these three interfaces. So we can select one interface at a time, or we can select multiple interface altogether. So it's your choice. So you can double click on the interface to start capturing the packet, or you can click on this interface and there's a button here, this shark button, fin, and here you can start capturing from here. Okay, so I will select my interface here. You can double click or you can click on here. So I will start capturing. Okay, now you can see the capturing has been started. So these are the packets. So these are like all Zoom packets. We are on the Zoom meeting. So that is why these are all UDP Zoom packets. Okay. Now, let's understand the interface of Wireshark. In the Wireshark, we will see this window. First, this window. In this window, we have three parts. First part is the main window. Okay, the main window. You can say this is the packet list pane, this one, where you will see the list of all the packets. Second window is packet details. Here you will see the list of, packet details of each packet and layer by layer. We have TCP IP model. In the TCP IP model layer, we have physical layer, then we have this data link layer, then with this transport layer, network layer, transport layer, application layer. So you will see packets layer by layer here also, like physical layer information, data link layer information, and this network layer information, transport layer information, and application layer information. So this detail is packet by packet. Then we have this packet bytes. So here comes our packet bytes. So let me show you the window. This is packet list where you can see the list of all the packets. So we can simply scroll down. Then we have this packet details here. These are the packet details. You can resize the windows. And these are packet bytes. So we have these three windows. When you open your Wireshark, you will see these three windows. Then, so the main interface consists of the menu bar, main toolbar, filter, packet list, packet details, packet bytes, packet diagram, and the status bar. So what is menu here? This part. This part is known as menu, where you will see file, edit, view, go, capture, these options. So you will find these options here. Okay, in the first page, this menu bar, file, edit, view, go, capture, analyze, and so on. And here you will see the file name here, which is main.pcap. Now, first we will see what each of these features contain. Okay, I will just give an overview, like which feature are inside which, under which feature. Then we will discuss that, like what every feature do in detail later on. So first we have this file. In the file, you will find we can open any file, we can close any file, we can merge files, we can export packets from any specific file. We can export this file in the form of CSV, plain text, etc. We can export objects, etc. Okay, so this is like an overview. What each and every feature do, we will discuss later on. Then edit. In the edit option, you will see if you wanted to find any packet, we can find any packet with the help of any name, with the help of any number. We can find next packet, find previous packet. We can mark any packet. If any packet is important for us, we can mark the packet. We can mark all display packet. We can ignore packet. We can make some changes here. We can see the packet comments and so on. Here you will see in the edit option, you will find the preferences option. From the preferences option, you can make changes in your Wireshark. If you are using Mac OS, then this preferences option will be inside file option. But if you are using Windows or Linux, then you will find this preferences under edit option. Okay, here. Then view option, we can tick on the option which we wanted to view. For example, let's say I wanted to remove this packet bytes, packet bytes. So here I can click on untake this packet bytes. Now you can see packet bytes has been removed. Let's say I just wanted to remove this packet details. So I can click on this packet details. So now we are left with packet list. Then you can also remove this main toolbar, filter toolbar, etc. And you can also tick on this full screen. So this will move to the full screen mode. Then there's an option of time. We will discuss these feature in detail because this is the main feature which we have to discuss whenever we are analyzing the packet delays. So time is very important in this, in this option. We will discuss what is the meaning of each and every time here in detail. But by this option only, you can analyze the packet delays. Then we have this name resolution. We will discuss later on. We can zoom in, zoom out. We can check the colors here. See, there are colors. For example, you can see this purple color. If I scroll down, you will see some yellow color. And if I scroll down, some more colors. Okay, so these are like colors. So what we can do, if I click on this view, coloring rules. So these are rules. These are like default rules by Wireshark. Wireshark is what Wireshark is doing. Wireshark is a smart application. It is marking your packet in the form of a color. For example, if a packet is a TCP packet, if a packet is a TCP, sorry, if a packet is a UDP packet, so it will mark purple color. If a packet is a TCP packet, it is marking as yellow color. If a packet is a, let's say, HTTP packet, so it will mark as a green color, and so on. So these are like rules here. Okay, so we will see this later for now. But these are rules. Then, if you wanted to disable, like if you wanted to disable these rules, then we can click on this option, this particular option, this option. By this option, we can disable the rules. So I can click on this one. Now you can see they're like no rules, no colors here. If I click on this option again, they're like colors here. So why we are having these colors? Like what is the need of these colors? Colors are mainly for the users. Wireshark is telling the users that this is the UDP packets and these are the TCP packets. So Wireshark is telling us this is mainly for the users so that we can analyze more easily, like which packet is of which protocol. So that is why we have this coloring rules here. Okay, so we will discuss in later what is exactly this rule is. Okay, then with this resize column, we can resize columns, we can reset layout and so on. Then with this go column, we can go to any packet. If you put a number, let's say I wanted to go on packet number 1500, then I can go to packet. Okay, by putting a number. Then we can go to next packet, previous packet. Like you can scroll down or up, or you can use your keyboard buttons like up and down for scrolling up and down. Or you can use these arrow. You can go to next packet, previous packet, first packet. Let's say you have multiple packets, like millions of packets. Then you can go to the first packet, like top packet, then the last packet. Then we have this next packet in the conversation and auto scroll. Okay. Auto scroll is like, let's say you are capturing in the live interface. Let's say I start capturing here. Let's say I'm capturing again here. Okay. So you can see this is auto scrolling. I'm not scrolling, it is auto scrolling. See, so this auto scrolling is because of I have enabled this option. If I disable this option, auto scrolling, see, auto scrolling has been stopped here. So if I enable, you can see this is auto scrolling the packets. So now I can stop the capturing. Okay, so this is auto scrolling. Then we have this capture option. In the capture option, you will find the interface settings. Let's say you wanted to make some changes in the interface. Then you can find this option from these options. Then you can start capturing, stop capturing, and restart capturing. Then here we have this capture filters, which we will discuss later. Then refresh interval. Sorry, refresh interfaces. Like you can refresh your interfaces. So if you have added new interfaces, then you can refresh it. Now you will notice the same buttons are here as well. Okay, like here. The same buttons you will see here. So we have the buttons here as well and inside this capture as well. So you will see we have many options for applying the same settings. Okay, that is a kind of a interface of Wireshark. Like we can start capturing from here as well, or we can start capturing from here as well. So we have many options. Then with this analyze, so from this we can check out some display filters that we will discuss later. Then statistics. From here, you can start analyzing your packets. Like let's say you wanted to check out the capture file properties. Okay, this is an example. So this statistics is like here you can choose any option and there are like multiple options for multiple protocols. You can select any option and you can start analyzing your traffic. So Wireshark is just analyzing your packets and providing some features for the user so that we can analyze. For example, there's a protocol hierarchy, this one, just an example. In this, you can see in the protocol hierarchy, they're like, it will telling you what kind of packets you have and at what percentage. For example, there's this Ethernet layer. Okay, like after frame layer, there's this Ethernet, like data link layer. Then here we have this IPv4. Here we have this IPv4 packet. So out of 100% of packets, I have 100% packets are IPv4 packets. There's no packet of IPv6 packets. Then out of 100%, 94% are of UDP packets. Okay, 94%, which means 1161 packets. So it is like a protocol hierarchy. It is telling you how many packets are of which protocol. So this is an example. We will discuss this in later, like in detail. Okay, like what is the meaning of each and every column here. For now, I'm just giving an example that in the statistics, these all options are for analysis purpose. We can analyze the packets more easily. That is why we have this statistics option. Then with this telephony for capturing the VoIP packets, wireless for capturing the Bluetooth packets. Then tools here, we can check out some firewall rules, credentials, and so on. The help here. In the help, you can visit manual pages of Wireshark. You can visit website. You can check out FAQs, Q&A. You can check out downloads. You can check out Wikipedia of Wireshark, sample captures, and so on. And here it is about Wireshark. So this will tell you everything about Wireshark, what kind of version you are using, everything. Authors. Now you can see these are the authors of the Wireshark. Like there are many authors here. So these are the person who actually contribute in the Wireshark, who have added many features in the Wireshark. That is why Wireshark is very wonderful application for now. Okay. We have many features here. Sorry, many authors here. Then we have this folder here where the Wireshark is in your machine. Plugins here. Wireshark is using these plugins. Keyboard shortcuts, you can change it as well. Acknowledgements and license. Okay. So these are the options in the menu bar. Then we have the main toolbar, like this one. So in the main toolbar, you will see these buttons. Now, what is the meaning of each and every button? We can see. First is start. This button is mainly for start the capturing. This one is for stopping the capturing. Restart capturing. This is for options. If you wanted to make changes in your interface, then you can click these options. If you wanted to open any file, you can click on open. If you wanted to save any file, you can click on save as. If you wanted to close, reload any file, then you can apply these options. Find packet. If you wanted to find any packet, then you can find. We will see this later, how we can find. This option is very useful for us. Then we can go back to any packet, go forward, or you can use up key or down key, or you can use the scroll bar for go back and go forward. Then go to any packet. If you want to go to any packet, then we can click go to first packet, go to last packet, same. Then this is for auto scrolling. So this will keep on scrolling the window. This is for colorizing. Okay, for if you wanted to enable or disable the colors, zoom in, zoom out, normal size and resize. These options you will find here. This one, these options. Okay. So let's see. Here we can start capturing, stop. Here we have these options here. So this will open the interface settings. And here we can open any file, close any file, reload. We can find any packet. We can go back any packet, go forward. We can go to the first packet. Sorry, we can find any packet, go to any specific packet. We can go to first packet. You can see packet number 1. Go to last packet, packet number 1229. This is for auto scrolling, colorizing, disable, enable. This is for zoom in, zoom out, resize. Okay, colors. Like these options. Then we have this filter bar. Here we can apply the display filters. Like we have two types of filters, display filters and capture filters. So we can apply the display filter here in this window. So in this window, we can apply the display filters. Even we can bookmark any filter. If you wanted to bookmark any filter, you can bookmark. This is for applying the filter. This button is for checking the recent filters. Okay, if I click on here, this button for checking the recent filters. So these are my recent filters. Okay, this is for adding filter as a button. If you wanted to add any filter as a button, you can add. Let's say there's a filter you wanted to apply daily on a daily purpose. Then you can apply filter as a button as well. Okay. So we will see what is filters, like what are filters and how we can apply it, how we can create. That we will discuss later. But here we can apply our filters. So we can bookmark, we can apply the filter, we can clear filter, we can apply, or we can press enter. We can check out recent filters. We can add button as a filter. And we can check out these buttons. Okay, like these are actually the buttons. So these are actually buttons. Then these are filters. Then packet list. Here comes the packet list. Is it clear this much? Any questions up to here?
No questions from my side.
Okay.
It's clear.
Okay. So here comes the packet list. This is the main window for us, the important one. So let me zoom in. Let me resize it just a little bit. Yep. So now what kind of columns we have in this window? So first we have this number column, this particular number column. Second column, we have this time column. You can change the time here. This is time. So we will see the time in detail later on. Type column, what kind of packet it is, IPv4 packet or IPv6 packet. Source IP here, this is my system IP. This is my system. Destination IP, actually it is I think it is a Zoom IP. Okay. UDP packet, protocol packet, like what kind of protocol it is, and information about packet. A very brief information about your packet. This is the source port here, the destination port, the length of your packet. Okay. With each protocol, you will find a different information here. This is a UDP packet. If I scroll down, see, this is the information of TCP packet, this yellow color packet. Okay, so this is the information of TCP packet. So you will see different information in different packets. Now, what is the meaning of each and every column? What is number column here? See, number column is important for us, but it will tracking your packets. For example, let's say we have number 1, number 2, 3, 4, 5. Let's say you are capturing packets, and let's say you have captured the TCP packet. Let's say TCP three-way handshake you are capturing, and let's say you have captured the TCP SYN packet. Then you have captured, let's say, some UDP packets. Let's say packet number 3 is also UDP. Packet number 4, let's say any ERP packet. And let's say packet number 5 is TCP SYN packet. So here you will see Wireshark will not going to capture your packets in the sequence. Wireshark will keep on capturing your packet no matter if the packets are in sequence or not. For example, let's say I am making a connection with a server, TCP three-way handshake. So this is my TCP SYN packet, and here is my TCP SYN packet. But I want in sequence TCP SYN, TCP SYN and TCP ACK packet. But you can see these are not in sequence. So let's say I am sending the request to any server, a TCP SYN request, a handshake request. And in the middle of that response, let's say my server takes some time to send me this packet, this SYN packet. It is a response packet. It is coming from the server side. So let's say this packet takes some few milliseconds. And within this milliseconds, some few UDP packets come and one ERP packet. So Wireshark will keep on capturing your packet, keep on, no matter if the packets are coming from same server, from different server, from other client, no matter. For example, let's say we have this client. Let's say this is my client here, and this client is communicating with, let's say, Amazon server. And let's say this client is also communicating with, let's say, Facebook. Okay, with Facebook. So let's say this client is sending some packets to the Amazon and receiving some packets from the Amazon. Same as this client is sending some packets to Facebook and receiving some packets from the Facebook. Now it is the client is operating simultaneously with the Amazon and with the Facebook. So the Wireshark will keep on capturing the Amazon packets and Facebook packet together. It is not going to capture the Amazon packet first and then Facebook packet first. No, it will keep on capturing the packet in the in line. Whichever packet is coming first, it is capturing. That is like a kind of a Wireshark mechanism. It will like keep on capturing the packet without any sequence. Let's say there's like some multicast or broadcast packets are coming to the client. So Wireshark will capture those packets also in the middle of Amazon and Facebook conversation. So that is why we have filters. We can apply the filter. Okay. So here you can notice these packets, let me go to the first packet. We have these UDP packets, and if you scroll down, they're like TCP packet in the middle of the UDP packets. Okay, like we have this TCP packet, this TCP packet, this packet here, TCP packet in the middle of UDP packets. So Wireshark will not going to capture your packets in sequence. So never assume that this number is in sequence means the packets are also in sequence. No, this number is mainly for the Wireshark. Wireshark is putting these number in your packet. This is packet number 1. This is packet number 2. This is the packet number 1 I have captured. This is the packet number 2 I have captured. No matter if that packet is of any other protocol. No matter. Okay. So that is number here. So we will use this number. Okay. But these are not the part of your packet. Numbers are not the part of your packet. Then with this time here, time we will discuss later on. So we will leave this as it is. Type here. So IPv4 or IPv6. Even you can resize your columns like this one. You can resize, or you can bring your column, like bring this IPv4 in middle. Like you can align in the left, in the center, or in the right. For example, if I click on type, right click on this align left. So this is in left. If I align center, so these are in center now. If I align right, these are in right side. Okay, right side. So you can align left, right, or center. Even you can change the column names. For example, I wanted to change this column name type. So I can right click and this option of edit column. I can click on here and here I can change the name. See, title. So let's say I just wanted to change the name to IP_type. Okay. Now you can see the name has been changed here. IP_type. So you can change the alignment of the test here and you can change the name as well. And we can also resize the columns like this. Then with the source IP address of my machine. Okay, so you can see packet number, this is arrangement. Packet number 1 is my machine sending packet to this particular destination. And it is this is my source IP, my IP, and this is the destination IP. Then protocol used in the communication and then information. So this is 51147 is my local port, like my source port. 80801 is my destination port. Then length of your packet. This is the information you will find. Now there's one more thing. We have these columns, like 1, 2, 3, 6 columns maybe. So now we can add columns, we can remove columns. For example, I wanted to add any other column. Let's say you can click on view and packet details. So this is my packet detail. So let's say in the packet detail, I have this packet, let's say this one, IP network layer. In this, you can notice we have many details here, many details. So what I can do, I can pick up any detail and I can add as a column here. For example, let's say length. I just wanted to add this length in the columns, in the packet list. So I can right click here and apply as column. This option, apply as column. So once I click on apply as column, you will notice this column here, see, length here. So we can align center. See, now this length is in middle. Okay, see this length. So we have added this length here. Also, if I wanted to add source port in the column, so I can right click, apply as column. Okay, now you can see source port has been added here. This one. And you can drag your source port. Like I can drag and I can bring it after source IP here. So now you can see we have IPv4, source IP, source port here. Okay, so we can also apply any details from the packet, sorry, any column from the packet details. Like you can pick up any detail. For example, this flag. You can right click, you can apply as column. Okay, you can take this destination port, right click, apply as column. And this one. Now you can see this destination port. Now you can drag and bring it here. So we have this destination and destination port here. Okay. Also, we can remove columns. For example, I wanted to remove this length column. This length column, I can right click on that column. And these are the list of my columns. So I can untick this length here. So now you can see length has been removed. Same as I wanted to remove this port here, destination port, I can untick this option. destination port. Okay, now you can see destination port has been removed. So we can add as many as column from here, and we can remove columns. This is one option. This is one option of adding columns from the packet details. Okay, there's another option that I will tell you later. But for now, this is first option. You can add any packet detail as a column. Okay, is that clear this much? Any question? So here we have this list of all the columns: number, time, source, destination, protocol, length, information. So you can go through this information. Now, we have packet details. What kind of information packet detail contains? So packet detail contains information layer by layer, and it follows TCP/IP model, not OSI layer. Okay, TCP/IP layer. So here you will notice that this frame layer, this is packet number 1. So this packet detail is the information of packet number 1. This packet detail is the information of packet number 1. So in this packet number 1, we have this frame layer. This is physical layer. This layer, this is data link layer. This layer, network layer. This layer, transport layer. And this layer is your application layer. Application layer is margin. Application layer, session layer, presentation layer. These layer are in this layer. Okay. So this is layer. And this detail will keep on changing when you keep on changing your packets. For example, this is packet number 2nd, where this packet number 2nd detail, packet number 3, packet number 4, packet number 5. So these are the layers of the UDP. Let's see the TCP here. See, this is packet number 96 and TCP. So you will notice physical layer, Ethernet, data link layer, IP layer, which is network layer, and this transport layer. So there's no application layer here in this packet number 96. Now, what each and every layer contain, we will discuss later on. Okay, but for now, here you will notice in the packet details, we have two types of information. Okay, we have two types of information. First information is, we have two types of information in the packet details. First information is the detail, or we can say the info, which is here two information. First information is the information which is coming and going with the packet. For example, here if you notice, source port, destination port. Okay, these are the details which are coming and going with the packet. Like it is the part of the packet. It is actually the part of the packet. Then we have second detail, which is the detail which is generated by Wireshark. Why? Because Wireshark is helping the users. Wireshark is helping their users so that we can analyze easily. So that is why Wireshark is generating their own details. Like Wireshark is generating some more detail for the user so that we can analyze easily. So the details which you will find inside square bracket. Okay, so the details okay, so the details which we find inside square brackets are the details generated by Wireshark. For example, you can notice this source port and destination port. These are packet detail. But if you notice here, this stream index, this one is inside the square bracket. And this conversation completeness, it is inside square bracket. So this detail is generated by Wireshark. Okay, this particular detail is generated by Wireshark itself. This one, okay, this one you can see, even this one. So the detail which you find inside square bracket, that is not the part of the packet. That is the information generated by Wireshark. For example, this one, sequence number raw. These are the information coming and going with the packet. Okay, because these are not inside square bracket. But this information, if you notice, acknowledgement number, this one, this is inside the square bracket. So this information is generated by Wireshark. Again, it is mainly for helping the users. It is just try to help the users that by providing some additional information. Otherwise, we cannot have this much information in a single packet. So if you see the information which is inside square bracket are the information generated by Wireshark. For example, these timestamps, these are the Wireshark information. Now, one more thing, if you notice here, a link here, see, this information is inside blue color. Sorry, this information is inside the square bracket and it is in blue color. Okay, it is in blue color, which means this is a link here. It is a type of link, and this is linking me to the frame number 87. What is frame here? Frame means packet number. We are on packet number 96. Okay, this is 96 packet, and this is saying that the part of this packet is on frame number 87. Means Wireshark is actually connecting your packets. What I said in the starting that Wireshark cannot capture packet in the sequence. So what Wireshark is doing, Wireshark is actually telling us that the part of this packet, this is packet number 85. So there's one more part of this packet number 85, which is inside another layer. Okay, for example, this one. This is packet number 87. So the acknowledgement segment of this packet number 87 is in packet number 85. So when you double click on this link here, you will move to packet number 85. See, now we are on packet number 85. You can notice the black line here, this black line. We are on packet number 85. If you click on packet number 87, now we are on packet number 87. Here you will see the link here. When you double click on the 80, this link, you will move to packet number 85. So it is actually a link here. Wireshark is linking the packets. Wireshark is, let's say we have this packet, a request packet and a response packet. Two packets, let's say, of any protocol, let's say ARP or DNS or ICMP, any packet. We have, let's say, ICMP request packet and ICMP response packet. So in the ICMP request packet, you will find a link which will take you to the ICMP request packet. Let's say the packet number of ICMP request is 1. And let's say the packet number of ICMP response number is 100. And in the middle of 1 and 100, we have many packets, other packets, UDP packets, TCP packets, any other packet. So in the ICMP request packet, you will find a link of ICMP response packet. And when you double click on the link, it will take you to the ICMP response packet. And in the ICMP response packet, you will find the link of ICMP request packet, which will take you to the ICMP request packet. So Wireshark is actually a smart application. It is actually connecting your packets, connecting your dots. Okay, so no matter if we have packets in the middle of 1 and 100, it is actually linking your packet. Okay, it is not showing CPS by CPS, but it is actually linking your packets. So that is like why Wireshark is powerful. Okay, so you will find details like one, which is coming and going with the packets, and second, the generated fields. So the information you will find inside square bracket are the information generated by Wireshark, and also you will find the links, which will find the relationship to another packet in the capture file. Okay. Also, the generated field will be TCP response time, TCP analysis, IP geolocation, etc. So these are the packet detail. Okay, now what each and every layer contain, it depends on packet to packet. Because in the TCP layer, you will find different information. In the UDP packet, you will find different information. So what each and every layer contain, we will discuss later on. Okay, now next we have packet bytes. So packet bytes are in the hexadecimal format. If you wanted to check out the packet bytes, so we can simply click on view and click on this packet bytes. So these are the packet bytes. So when the packet bytes are useful, we can say whenever you are, let's say, analyzing any malware, analyzing the bytes, then you can see packet bytes should be useful, but it depends on the scenario. So that is packet bytes. It depends on the scenario, like when you wanted to use packet bytes, then it may be depend on the any specific situation, like whenever you are analyzing for malware maybe, or whenever you are analyzing any packet which is where you wanted to analyze its packet bytes, then you can see you will need this packet bytes, but not in every scenario. Then with this packet diagram, so this will show you the diagram of any packet, like what this packet contains. So we can see either packet diagram or packet bytes, any one of these. Because there's a limit, we can see 3 windows at a time. One window, second window, and third window. Now, if you wanted to add another window, which is packet diagram, then you have to remove any window from here and then you can add packet diagram. For example, I wanted to see packet diagram in place of packet bytes. So I will remove the packet bytes from here and I will add packet diagram. So how I can add? You can click on edit. There's the option of preferences and there's the option of layout. Fourth option, layout. So here you can see we have pane number 1, pane number 2, pane number 3. In the pane number 1, we have packet list. You can tick on any other information you wanted to see. Packet pane number 2, packet details, and packet pane number 3, packet number bytes. Packet bytes, sorry. So you can tick on this packet diagram. Okay, so I wanted to see the packet diagram instead of the packet bytes. So I can tick on here and click on OK. Now I can click on view and tick on this packet diagram. Now here comes my packet diagram. This one. Okay. So this contains the information of the packets, like what kind of information this packet contains, like the header information. Okay, like the MAC addresses, the IPv4, we have this version information, header length in the IP layer, like in the network layer, identification number, flags, etc. And this is UDP layer. In the UDP, we have source port, destination port, checksum and length, and payload layer, and the data layer, like application layer. So this is a packet diagram, which will tell you about the packet, like what kind of headers it contains, like what kind of information it contains in each packet. So again, it depends on the scenario. Like commonly, we don't use the packet diagram and packet byte that much. Then we have this status bar. This is again very important. Status bar is important. So what I can do, I just remove this packet diagram. It is distracting. Yeah. Now we have this packet list and packet bytes. Sorry, packet details. So here you can see this is the status bar. Sorry. This one. Here, this is the status bar from up to here. So let me remove this one. Yeah. So first here, this will show you how many packets are there, which is total number of packets. So we have around 1229 packets, which is 1200 around packets. Then we have this displayed packet, which is again 1200. So what is the difference? This is total number of packets, like how many total number of packets are there. But when you apply any filter, then you will see some few packets. For example, let me show you. Let's say I'm applying a filter here. I wanted to see TCP packet only. So I will apply TCP filter here. Enter. So now you can notice the status bar. Out of 1229 packets, 67 packets are displayed. Means 67 packets are visible here in the screen. For example, in the packet list, we have this 67 packets. So there's no UDP packets because here I have applied a filter TCP here. So I just wanted to see the TCP packet. So you can see out of 1229 packets, 67 packets are of TCP packets, which is 5.5% of your overall packets. Then here you can notice the name of your filter here, this side, left hand side. This is the name of your filter in the full form, which is transmission control protocol, and it is a kind of a protocol. This is like a full form of your filter here. Okay, if I remove the filter, see, if I just remove the filter from here, then you will notice the file name here. Okay, this is a file name. So if you are not applying any filter, you will see a file name here and overall packets, total packet size, they are like both same because there's no filter here. Wireshark is displaying all the packets. So there's no filter actually. So 1229 packets overall. And display packets are also overall 1229. Then here you will see in the corner, there's a profile option. Now what is the meaning of profile? See, what I'm doing, I'm changing my profile. This is my default profile. I click on this profile and there's some profile here. There's a profile of security analyst. So once I click on the security analyst profile, see, you will notice something has changed. Even the entire interface of my Wireshark has changed here. If I switch back to the profile of default, you will see the change in the interface. So what is the main purpose of this profile? Let's say there's a system. Okay, there's a system one. And in the system one, there's a Wireshark installed, let's say. And you have three members in your, let's say three employees here. Let's say one is a security analyst. Second is a, let's say, a network engineer. And let's say third is an application developer. So let's say there are three members in a company, and they all are using the same machine for using for capturing the packets, Wireshark. Okay, like there's a system in this system we have Wireshark installed, and we have three members. These three members are using the same machine for using the Wireshark. Like you can think of a scenario where you have one machine, and you have only the permission in this machine to install Wireshark and install and capture the packets. In that case, you will see these three users are using the same Wireshark. So in that case, let's say there's some requirement for the security analyst, there's some requirement for the network engineer. Like they are analyzing different traffics. So now what they will do, they will change the Wireshark interface as per their preferences. Let's say I'm the security analyst. I wanted to change the preferences of Wireshark as per my requirements. So if I click on the security analyst, this is my preference. I wanted to see the packet color orange, and I wanted to keep my window like this one, packet list and packet detail. This is my preference. Let's say there's some other user, app developer. If I click on here, you can see this is the preference of the app developer. So what I'm saying is we can make changes in the Wireshark. Like we can change the entire interface of the Wireshark. Like we can change colors, we can change layout, we can change panels, like panes, we can change the filters, like we can change anything in the Wireshark if as per the interface. And if one interface will not affect the other interface, that is why we have this profile option. For example, if I click on the security analyst profile, you will notice my profile is not affecting any other profile. For example, if you notice orange color here, this orange color is for the UDP packets. I wanted to keep my UDP packet color orange colors so that I can recognize it. But if you notice the different profile app developer, the color of the UDP packets are this purple color, light purple or blue, I don't know, this color. Okay. So you can see one profile settings not changing the profile of another, interface of the another profile. So that is like the benefit of creating the profiles. If you have multiple users and you all are using the same machine for the Wireshark, and then you can create your own profile, make changes in your profile, change colors, change layout, change filters, change settings, any settings, and then you can start capturing and analyzing the packet. And the same, the one interface will not change the other interface of any other profile. That is like the main option, like advantage of creating a profile option. Okay, like here, how we can create a profile? You can simply right click, and there's an option of manage profile. You can click on manage profile. Yeah, but there's no security here. One person can delete the profile of any other person. Even one person can change the profile, like the interface settings of any other profile. So there's no security here. But we are just changing the profile. So that is why there's no security. That is not a big deal. But again, you can change any other profile. You can delete the profile of any other user. Okay. So you can see we can create a new profile. Here, there's option of plus option. You can click on plus. Now you can name your profile. Let's say a network underscore engineer. Okay, personal profile, because it is not a global, a personal profile. And you can click on OK. Once you click on OK, there's another profile, network engineer. So now we have four profiles, network engineer, security analyst, app developer, and default, four profiles. And the changes of one profile will not affect the changes of the another profile. That is the main purpose of this profile option. If you wanted to remove profile, then again, you can manage profile. There's a minus option. Let's say I wanted to remove this network engineer profile. I can click on this minus. Profile removed. So anyone can remove any other profile. Anyone can make changes in any other profile. So as if there's no security, but what is the purpose of security here? Okay. So this is the status bar. Any questions? Anything which is not clear up to here?
It's okay.
It's okay, man.
Okay. So this is the main purpose of the status bar. We will see the total number of packets, how many packets are displayed out of total number of packets, profile option, and the filter name and the file name. That is the status bar. So this is all about the interface of Wireshark. Okay, like you have to play around with the Wireshark so that you can get familiar with the interface of Wireshark. Okay, like you can just play around, you can start capturing packets after the session. I mean, you can start capturing, just check out some packets, check out packet details, see some options, etc. Now, we can move to some theoretical part of Wireshark, like a kind of a network engineer theoretical part, like a kind of a checklist. So here we have a definition of a network analysis. So what is the main purpose of network analysis? It is like it is mainly for analyzing, controlling, monitoring, managing the network traffic. So now what is the purpose of actually analyzing the traffic? Like why are we analyzing the network traffic? So like we have various reasons. First, we have to understand the architecture of the network. So we can use Wireshark for that. Secondly, deep understanding of the structure of the network. We can troubleshoot networks if there's any problem like packet loss, packet, there's some latency, there's some error in the packet, etc. Even you can know that where's the problem is arising from. Is it from the server side? Is it from the client side? Or is it in the middle of some server and client? So you can also understand the real problem. Then performing the security operations for identifying the security incidents like any malware traffic, any port scanning. If someone is scanning your network, you can understand. If someone is gathering information about your network, then also you can know, okay, that is analyzing or performing some security operations. Then learning more about network protocols at a microscopic level. Like here you can notice, we are actually analyzing the packet layer by layer, like what each layer contain in this packet or in this type of packet. So we are having the very fine details of the packets. Then we can also perform the analysis on VoIP packets. So we will see in later sessions, like how we can capture the traffic of, like how we can analyze the traffic of VoIP. So this is like how we can define the purpose of the network analysis. Then we have this troubleshooting task. So we are not going to perform operations like mentioned here. These are like just theoretical aspect, like which you can use, which you can perform with the help of Wireshark. So what are the troubleshooting tasks for the network analyst? He or she can identify the problem, check for the hardware if there's any problem with the hardware, perform any DNS check, contact the ISP, check for the viruses, review the logs, and document the issue. Give me a second. Yeah. So here, a network analyst can perform these operations. Then, security task for the network analyst. Network analyst can also perform some security task, like he or she can monitor the network with the help of Wireshark. He or she can maintain the security of the network while checking for the malware, checking for the malware traffic, checking even for the some vulnerabilities, and so on. Then he or she can implement the firewalls, segmentation, IDs, and IPs. We can also implement some security measures, and we can check if that security measure is useful or not. Okay, then we can find the network vulnerabilities. We can serve as a active part in the incident response team. Okay, like the team which is responsible for investigating the attack. So we can also investigate any attack. Uh, we can also submit our results, whatever we have find in the network traffic, like some malware activity and so on. We can also provide some support to the relevant stakeholder and so on. We can also update the technology, and we are responsible for planning of any security assessment. Like we can become a part of it. Once you know about packet, once you know about the network, once you know about the architecture of a network, like how the data is flowing in your network, like what each and every packet contains, then you can also become the part of any other team so that you can add some, like you can contribute and you can add your insights in that team. Like what you find in the network, if there's any vulnerabilities and so on. Then here's some optimization task for the network analyst. Like they can use proper tools and techniques, implement some long-term strategy, sustainable strategy for the network. Okay, then support and provide information to the network engineers, management of unplanned emergency events, and so on. Like support the network engineer and risk analyst. Then we have some application task for the network analyst. If let's say if there's any application developer, he or she wanted to take your help for analyzing their application, their protocol, then you can also contribute there. Like you can analyze their application, analyze their protocol of the application, document the process. Okay, you can also mention some recommendations or some improving points. You can keeping up with the advancements in the application with the network technologies and solutions and so on. So these are like some a kind of a you can think of a checklist what kind of task a network analyst can perform. Okay, so it depends. Now we have some legal issues, as I said in the starting, that for capturing in the network, let's say you're capturing in your company, so they like some certain ethical considerations you have to make, like some legal compliances you have to follow for capturing in the network. Because in many companies, there's some legal policies, like you cannot capture the data of the traffic because, sorry, data of the network because you are violating the confidentiality there. Okay. So in that case, you need some permission before even capturing in your company. So before capturing, just check out the policies, check out the compliances, what your company follows and what the country follows. So this legal compliances or legal issue, like it depends or vary from company to company, even from country to country. So they're like some data protection acts, some other act, which will not allow you to capture the traffic in the company. Okay, or maybe you cannot capture the traffic of any specific machines like admin, some server, and so on. There are like many issues with the Wireshark. So before capturing, you should have a proper permission for capturing. For example, there's a legal issue in the US, so you can go through this one. Okay, so you cannot capture, simply go and capturing is not valid. Okay, so it may maybe considered like a kind of illegal task. So before capturing, just check out your company policies or procedures. So, okay. So this is all about the Wireshark interface and Wireshark, like some theoretical. Okay. Now we can move to a very important part, which is known as display filters and capture filters. And before that, there's an option in the Wireshark, which is known as name resolution. So what is the purpose of name resolution? See, there's an option you can click on view, sorry, edit and preferences. And here we have this name resolution. First, I show you the file without name resolution. Then I will show you with name resolution. Okay. So just, this is a simple file. First, you open your Wireshark, then you will see a simple file like this. Here you will notice the number here. Like source IP is a number here. Source port is a number here. Destination port is a number here. Protocol here. Okay. So here you will notice numbers in place of name. For example, 192.168.139 is the IP address. Destination IP, source port here like 62274 and some port here. Even you can see the MAC addresses like this one. Like here you can notice, just notice here, like here we have the source MAC address and destination MAC address. Okay. Now, if I enable the name resolution, then you will see the difference. Okay, so you can click on preferences. There's option of name resolution here, this one. Click on here and click on first four options. Resolve MAC address, resolve transport names, resolve IP names, address, and use capture DNS packet data for name resolution. First four option and click on OK. Now you will see the difference. See, what is this name resolution doing? It is converting your IP address into a predefined name here. For example, my system. So this is my host name, laptop something, BP router. This is my name, my system host name. Okay, now here you can see this is like a name here, resolve name. Now it is Wireshark is not identifying the Zoom IP. So that is why we have no name in place of Zoom IP. But let's say you are capturing, let me show you a file in the Linux. I think we have this file. Yeah, for example, here you can notice this name here, this source IP, there's a name of my machine, and this blockchain.info. This is a website which my PC is communicating with. So blockchain.info is my is a kind of website which or we can say a server where my machine is communicating. So instead of the IP address, we are seeing the names. Okay. See here you can see they are like all names. This is just a IP address. So the name, like the IP which the Wireshark is not able to like recognize, then the Wireshark is printing IP as it is. But if Wireshark knows the name of any system or the website name, domain name of any IP, then Wireshark will display the IP address. That is like the name resolution. It will convert your IP into a proper name. So same as you can notice here, the port number name. So we have how many ports are there? We have 65535 ports, out of which 1024 ports are known ports. Rest are unknown ports. So Wireshark can only identify the known ports. Okay. For example, HTTP port number is 80. HTTPS port number is 443. For example, SMTP port number is 25 and so on. So Wireshark can identify the known ports. So you can see 62759 is an unknown port. 8801 is an unknown port. So let's find unknown port. Do we have any known port? Yeah, here you can see 61667 is an unknown port, but HTTPS 443 is a known port here. So in the brackets, you can see number, but here you can see a name here, HTTP. So this is all because of name resolution. So it can resolve your port number. It can resolve your IP name, like converting your number into the names, and it can also convert your this thing, MAC addresses. For example, if you notice here, this is the MAC address. We have this MAC address of my machine, and here we have this name here. Then with this Reliance, this is the MAC address of something else, and the MAC address here. So it is also resolving the MAC address as per the company. Because as you know, first few characters are of the company. So by seeing the MAC address, we can know the this company name of that MAC address. So it is resolving the IP address first, then the port numbers, and second, third, the MAC addresses. If you wanted to check how the Wireshark is resolving, then there's an option here in the statistics, which is resolve address. In the resolve address, you can see these are the ports in this file. So these are the ports the Wireshark is resolving. 53 for the DNS, HTTP 443, and so on. And for the host, you can see these are all the list of the host, which Wireshark can resolve. So Wireshark will match the MAC address with the MAC address which is present here, the IP address which is present here, and then convert the IP into the provided name. For example, you can see this is the Zoom IP. So in place of Zoom IP, we will have this name here, zoom.us. I think we are using the different IP, that is why. Let me check. 110170. So we can match. It is also Zoom IP. Yeah. Here you can see this IP. 170.114.107.67 is a Zoom IP. But if you notice here, this one is again a Zoom IP, but these IP are different. That is why Wireshark is not able to recognize that is this a Zoom IP or not. So this is not a Zoom IP, but I know it is a Zoom IP because uh, we are connecting over Zoom. So that is why we have lots of UDP packets. So if you wanted to see the address in your machine, then you can see from here. The more packets you will capture, the more uh, Wireshark will keep on adding the recognized name. For example, let's say you visited Amazon.com and there's an IP of Amazon. So Wireshark will recognize the IP address of Amazon and put here that this is IP of Amazon and the name here. Then next time you will capture the packets of Amazon with the same IP, then Wireshark will flag that IP as a Amazon.com IP. So that is the whole purpose of name resolution. It is like converting your IP into the names and this code number into a name, MAC address into a name. So this is how we are resolving. So you can also enable and disable the name resolution from here. View, there's the option of preferences. From here, there's a name resolution and you can click tick on first four options. First four option. Fourth option is for it will convert the IP into the domain name as per your DNS, as per your domain name system. Okay. The cache memory which you have in your machine. So this is the name resolution. And one more thing, how I know that this is a Zoom IP. So there's one more option. You can open the, let me show you. Who is lookup? I think you know. You all know the who is lookup. One second. So here you can paste the Zoom IP so that you can know, okay, it is a Zoom IP or not. So let's see. We can copy this IP. How you can copy it? You can double click on this one. This will open the packet details. So you can also double click on any packet and you can open the packet detail. And you can tick on this option to show the packet bytes. Okay. So there's the option of IP here. And here we have this source destination address. You can right click, copy this value. And we can paste here so that we can know if this is a Zoom IP or not. So you can see this is the Zoom IP. Okay, so you can visit this who is lookup for checking. If Wireshark is unable to recognize that whose IP is this, then you can visit the who is lookup to check whose IP is this. So that is additional part. Okay. Is it clear this much? Any questions?
It's clear.
Yeah, it's clear.
Okay. Now we can move to the filters. So we have two types of filters in the Wireshark. First thing is Wireshark follows a specific syntax for the filters. Okay. So if you wanted to apply the filter or if you wanted to create any filter, then you have to follow a specific syntax that is particular, that is important. Then we have two types of filter, capture filter and display filter. So capture filter you apply whenever you are capturing any packet. So this you apply before capturing the packets, before starting to capture the packets. For example, let's say Wireshark can capture all sort of packets like TCP, UDP, ICMP, HTTP, multicast, broadcast, all sort of packets which are coming to and from your interface. So let's say now I just wanted to capture the packets of TCP only, just TCP. So I can tell Wireshark that please capture the packets of TCP and don't capture any other packet. So this is capture filter. So before capturing the packet, you will tell Wireshark that I wanted to capture the TCP packet or I wanted to capture the packet of any specific IP address. Let's say I wanted to capture the packet of this IP only. So I can tell Wireshark individually that I want to capture the packet of this particular IP. That's it. So how you can tell? So here, if I use the Wireshark, yes, Wireshark is not working. So let's restart the Wireshark. Here we can apply the filter. This is a capture filter, this one. Now let's say I just want Wireshark to only capture ICMP packets. Okay, now you will notice here, this particular part, this one, if it turns green in color, which means you are typing correctly. If it is in red in color, for example, this one, this line is red in color, this box, which is you are typing, your syntax is wrong. But if you're typing everything right, this will turn green in color. Okay, that is a sign whether your syntax is correct or not. So let's say I wanted to capture the ICMP packets only. So I am telling Wireshark before capturing that I wanted to capture the ICMP traffic. This is capture filter. Okay. Now let's say I just start capturing here and apply the filter ICMP. And then here I can start capturing. So we don't have any packet, no ICMP packet. So what we can do? We can generate some packets. So we can ping, let's say google.com. Okay, now you can see in the background, we have some ICMP packets. Just ICMP packet. Otherwise, we are communicating over Zoom. We should have Zoom packets, but we are not capturing that packet. Because I have told my Wireshark that please capture the ICMP packets only. So here you can see these are all ICMP packets. Even these two packets are ICMP packets. So these are all ICMP packets. So I'm telling my Wireshark individually, please capture ICMP packets only. Now, we have many filters, many capture filters. What we can see, what we can do, we can click on this capture here. And this option of capture filters. We can see Wireshark default capture filters. See, these are Wireshark default filters. So if you wanted to apply the filter on the basis of MAC address, then you can put this one, Ethernet host, this one. This is for the MAC address. You can put Ether, your host, and here comes your target MAC address. Then this is for the ERP packet. Okay, if you wanted to capture the ERP packets only, this is for this one, this one. If you wanted to capture the packets of your interface only, like if I wanted to ignore the broadcast and multicast packet, so I can put not here. Okay, not here. Let's say I wanted to capture the packets of every protocol apart from ICMP. So I can put not ICMP. So this will not capture the ICMP packet and capture every other packet. So that is not ICMP. You can put not if you wanted to ignore that packet. Let's say I just don't wanted to capture not broadcast packet and not multicast packet. So now I'm ignoring the broadcast and multicast packet. That is, you can put not. Let's say I just don't wanted to capture the IP address of this packets of this IP address. So I can put here this IP. Okay, or any IP of your choice. Okay, so you can put not before any filter so that you can capture the packet of every protocol apart from that particular filter. Same as you can see not ARP. If you wanted to capture IP packet only IPv4, you can put IP single. If you wanted to capture the packet of any specific IP, you can put host and the IP address. This is for the IPv6. This is for the IPv6 IP address. This is for the TCP, UDP. This is for not DNS. This is for the port number 80. This is for the HTTP and so on. And this is for, we are combining filters. See, here we have this filter. So let me copy this filter. So what this filter is saying, this filter is saying that I don't wanted to capture the 80 packet. What is 80? HTTP packet. So I don't wanted to capture the HTTP packet. I don't wanted to capture the SMTP packet. But I wanted to capture the packets of only this particular website. So we are actually combining the filters with the help of AND operator. Okay, this is AND operator. So we are combining with the help of AND operator that I don't wanted to capture the packet of HTTP, SMTP. I just wanted to capture the packet of this particular website. So Wireshark will follow you. It will just remove the HTTP packet. Eventually, it will not capture the HTTP packet, SMTP packet, and it will only capture the packets between your machine and this website, this particular website. So that is the power of capture filter. You can apply any kind of filter, just follow the syntax. Let's say I just wanted to capture the SMTP traffic. I can put SMTP. Let's say I just wanted to capture the packet of ARP. I can put ARP or not ARP. Or let's say I just wanted to capture the packet of this IP address, but not HTTP packet. Or you can put port number 8. Okay, you can also put simple port number, any port number you can follow. Let's say I just don't want you to capture the packet of port number 1224. Okay, so let me close this file. Here I can put port number 1224. I just wanted to capture the packet of port number 1224. So now this will capture the packet of port number 224. Now this port number should be on the source side or on the destination side, no matter. Let's say my machine is using port number 1224. So this will capture the packet of 1224. Let's say the destination machine is using port number 1224. So again, Wireshark will capture the destination packets. So no matter if the port number is on the source side or on the destination side, Wireshark will capture port number 1224 packet. Like wherever the Wireshark will see the involvement of 1224 port number, it will capture. Okay, so what I do, we don't have any packet of 1224. So what we can do, we can remove this one and we can use 80 port. Let's say I just wanted to capture the packet of HTTP. So I can start capturing. Even you can see here on top, your filter here in the brackets, this one, port number 80 here, this one. So we don't have any packets. What we can do, we can generate some packets. We can visit this website. It is a HTTP website, oneweb.com. Okay, so this is a HTTP website. You will see some packets. These are all HTTP packets. Okay. Here you can notice one more thing, that we are capturing the TCP packet as well. So when I apply this port number 80, so Wireshark will capture the packet of HTTP plus TCP. Why TCP? Because HTTP works under TCP. So whenever we are using HTTP, which is working under TCP, we have to make the connection. So TCP packets are for connection packets. So it will capture the TCP connection packets and the HTTP packets like this. So these are, you can see CCNA packet, like TCP packet and some HTTP packets. Okay. Moreover, here if you put here simple HTTP, what will happen? Simple HTTP means this will only simply capture HTTP packets, no TCP packets, no TCP connection packets. Okay, let me show you the difference. If I close this file, I don't want it to save. If I apply the Wireshark again, here I can apply simple HTTP. There is no filter for the HTTP even. HTTP is no. So there's no capture filter simply for the HTTP. So we can just put port number 80 like this. So overall, we cannot simply capture the HTTP traffic without capturing the TCP connection packet. So there's no such filter. I think right there is no such filter. Okay, so we have many filters. Let me show you a file, some new filters. Just a second. Yeah. So here with this capture filters. So let's see some common capture filter which you will going to use regularly. Again, they are like all same. So we have limited number of capture filter, then display filter. Because capture filters depend on the scenario, like what kind of scenario you are you're capturing on. So we have these limited filters, and even you can create your own filters. Okay, you can just replace the IP with your own IP. You can also mention the website you wanted to capture on, like this one, and so on. So after the session, I will provide a cheat sheet for the capture filters and for the display filters. There you will find the list of all the capture filters which you can use on the regular basis. So first you can create your own filters with the help of the syntax provided here. Secondly, you can follow a cheat sheet, or you can just Google the filter you wanted to, capture filter you wanted to use. Like you can explain your scenario and you can generate a capture filter. So it depends on totally on the scenario. Otherwise, these filters are sufficient. Okay, you can combine multiple filters with the help of AND operator. There's one more thing I just wanted to mention. See, here we can capture on the multiple interfaces. Let's say I wanted to capture on interface number 1, 2, 3. Okay, let me remove a filter. So now let's say I wanted to capture the packets on 3 interface at a time, 1, 2, 3. So that I can capture. How you can capture? You can just simply select your first interface, press the shift key, keep on pressing, and select the third interface and remove just unpress the shift key. Like you have to select all these uh, interfaces and then click on start capturing. Let me stop the capturing for now because we have many packets. Now you will notice 3 interfaces, or at top, 3 interfaces. Also, how I know that which packet is of which interface? Like how do I know that if this packet is a packet of interface number 1, 2, 3? So this option, you can click on frame layer, and there's an interface ID number. Interface ID. You can right click, again apply as column, so that you can know which packet is of which interface. See, these packets are of interface number 2nd. These packets are of interface number 0. Why 0? Because we are capturing on 3 interfaces. And numbers start from 0, index number 1 and 2. Which means first interface is the interface number 0. Second interface is interface number 1. Third interface is interface number 2 here. So the index numbers start from 0. And even you can check out the interface name here. This is the interface name which we are capturing. So this is interface number ID and interface number name here. Also, if I scroll down, you will see interface number 2 packets. So interface number 0 means interface number 1. These are in sequence. Interface number 1 is interface number 2. Interface number 2 is interface number 3 here. So we have mainly the packets of interface number 0 and 2. Okay, yeah. So what I'm telling is, I am capturing on the multiple interfaces. So what I cannot do is, I cannot use multiple capture filters on multiple interfaces. For example, I'm capturing on 3 interfaces, 1, 2, 3. So I cannot apply different capture filters on different interfaces. That is not possible in the Wireshark. Let's say in the first interface, I wanted to apply the filter HTTP. In the second interface, I wanted to see the ARP packets. In the third interface, I wanted to see all the packets. So I cannot do this in the Wireshark. So here I cannot do this in the Wireshark. Wireshark will not allow you to apply the multiple different capture filters on multiple different interfaces. But we can do this in the T-Shark. Okay, that we will see later. So this we can do in the T-Shark. We can capture on multiple interfaces and we can apply different different capture filters in the different interfaces. And one interface capture filter will not affect the another interface. So that is, we cannot do in the Wireshark, but we can do in the T-Shark. Okay, so if you wanted to try, you can try, but we cannot do in the Wireshark. We cannot capture in the multiple interfaces. So is it clear this much? Any question?
Yes, ma'am.
Yeah, it's clear.
I have a question.
So what we can do, we can discuss the display filters. So Display filters is mainly for analysis purpose. This is capture filters. Display filter we use for analyzing purpose. Let's say I have many packets. Okay, like I have all sort of packets. TCP, UDP, every packet. Now let's say I just wanted to see the TCP packet in my network. So I can use a display filter. Display filter is mainly for the analysis purpose. Capture filter is mainly for the capturing purpose. That is the main difference. Display filter you apply after capturing the packets. After capturing means whenever you are capturing, once you start capturing, then you apply the display filter. For example, here, this is my file. I have around 932 packets in this file. Okay, you can see from the bottom pane, status bar, 932 packets. Now let's say I wanted to see just TCP packet. I can put TCP here. This is TCP packets. These are all TCP packet. For the UDP, I can put UDP here. These are all UDP packets. For the HTTP, we can put HTTP, no packet, DNS, and so on. So whenever you wanted to apply the filter on the basis of protocol, then we can simply use the protocol name here, ARP or ICMP or UDP, TCP, DNS or any port, any protocol. Then if I wanted to capture on the basis of IP address, I can put ip.addr equal this IP. For example, I wanted to check the packets of this IP. So here I can put ip.addr equal IP address 192.168.1 no 2996. I'm applying this IP. Enter. So you can see we are just here. You can notice we have like 932 packets overall. 932 packets. Out of 932 packets, 743 packets are visible. Why? 743 packets contains this IP, either on the source side or on the destination side. Okay. Here you can see this is on the source side, 192.168.2996. Here you can notice it is on the destination side. So no matter where, it is either available on the source side or on the destination side. If you are putting ip.addr equal this IP. If you put ip.source, SRC, source. So now you will going to see this IP on the source side only. Okay, here you will see these all packets contain the same IP on the source side. Same IP. Same as we can put DST here for the destination IP. DST. So this is on the destination side. 192.168.2996. 192.168.2996. Everywhere on the destination side. Even you can see the number of packets now. Just 71 packets containing this IP on the destination side. Okay. Now, in place of equal sign, you can put not equal. Let's say I just don't want you to see the packet of this IP. So I can put here address not equal this sign. So this sign is mainly for not equal sign. Here we can put another filter, which is i3.adr not equal sign, and any IP of our choice. So not equal means I just wanted to see the traffic of every IP apart from this IP. That is not equal. Okay, so here we can put not equal and enter. You can see out of 932 packets, 185 packets are displayed, which means this IP is like a kind of a special IP, like important IP for my traffic. Because just we have 185 packets, which are even the local host packets. So maybe this IP is my machine IP, maybe. Okay. So here we can apply the IP.source, IP.destination, and IP.not equal sign. Okay, like this. IP source, IP destination, and not equal sign. So this is if you wanted to apply the protocol, display filter on the basis of IP address. And this is for if you wanted to apply the filter on the basis of this protocol here. Now, here we can put port number as well. For example, like this one. If I wanted to see the packet of TCP, so I can put TCP.port 8080. 80. So here I can put here TCP.port number equal 80. I think we don't have any packets of HTTP. Same as I can put 443 for the HTTPS Okay, we have some packets for the 53. This is for the DNS. No packets of DNS working under TCP. See, if I put here UDP dot port number equal 53, we have some packets because these are DNS packets working under UDP. Again, 53 port number can be on source side or on destination side. If you wanted to see on the source side, you can put SRC. SRC. If you want, now here you can notice, do we have the source IP? We can add a column here. No column. Here we can add a column for the source port so that we can check. See, source port, we can right click, try call. So here you can notice source port, same source port here, DNS. While if I try this destination port as column, see, different IP. Same as if I put in place of source port, I put DST. You can notice this 53 IP on the destination side here. Destination port 53 everywhere. So we can put any IP, you can put any port number, and you can choose where you wanted to see, either on the source side, destination side, or both. So this is how you can apply the filter on the basis of port number. Then we can combine filters with the help of two operators, AND operator or operator. These operators are known as logical operators. Let's say I wanted to combine filter. Okay, let's say I just wanted to see the packet of this packet. See, what is the difference in the AND operator or operator? Let's say we have a scenario, this one. Let's say we have number here, 5 is greater than 6 and 4 is greater than 5. So this condition and this condition, there are two conditions here. One condition is 5 is greater than 6. This condition is, 7 is greater than 6. This condition is true. But 4 is greater than 5. This condition is false. So here, one condition is true and one condition is false. So what will be the answer? False. Because in the AND operator, we are checking for both conditions. If this condition is true and if this condition is true, then only we have the true answer. Okay, otherwise false. Next, let's say if I put here, in place of 4, I put here 8. Now, this condition and this condition both are true. So we will have the answer true here. Because AND checks for both conditions. If both conditions are true, then only we have the answer true, otherwise false. But if I put here OR, if I put the same condition as OR, let's say OR, so this condition is true and this condition is true. We have the true answer. If here we have 4, now this condition is true and this condition becomes false. But still we have the true answer. Why? Because OR checks for one condition. Here I can write OR checks for one condition and AND checks for both condition. Okay, that is like the main difference. The same phenomena we can apply here. Here you can notice if I apply this filter. Okay, notice this filter here. UDP dot port number 53. So I am checking. I just wanted to check the DNS port which is working under UDP. So these are the packets. How many packets? 20 packets. Now let's say I put here TCP port in place of UDP. TCP. We don't have any packet. I don't have any packet which is working under TCP and that port is DNS. I don't have any packet. So what if I combine this filter and this filter? Can anyone tell me what will be the result of this filter?
False.
Sorry?
It's a false result.
If I click on enter, you will see no output here, no packet here. Why? Because we have the packets of this file, this particular filter. We have the packets of DNS, which is working under UDP, but we don't have the packets of DNS which is working under TCP. And here we are using AND condition. AND condition checks for both. So Wireshark will check for both. If Wireshark find the packet of DNS working under UDP and packet of TCP DNS working under TCP, then only Wireshark will show me the packet. Otherwise, not. So this condition and this condition both needs to be true. Here this condition is false. TCP condition is false. That is why we don't have any packet. Okay, irrespective of we have packet of UDP, but we are not having any result here because here we are using AND condition. AND checks for both condition. If I put here OR, you will notice some packets because any one condition is true here. Which condition? This condition. This condition is true, but this condition is false. But for the OR condition to execute, we only check for one condition. So OR checks for one condition. So no matter if I don't have any packet of DNS working under TCP, but I do have the packet of DNS working under UDP. So that is the main difference in the AND or OR. And with the help of this mechanism only we combine the filters. For example, again, we can use source port here. Okay, like this one. For example, this filter. I wanted to see the packet of any IP. Let's say this IP 192.168.2.9 and this 96. And here I can also use ampersand. Okay, double ampersand. HTTP. See, I do have the packet of this IP, but I don't have the packet of HTTP. That is why it is showing me no result because I am using an AND condition here, which is it will check for both conditions. But if I apply OR here, we can use pipeline for the OR. Okay, double pipeline. You can see we have some packets. So we have the packets of involvement of this IP. Okay, this IP. No matter if it is an HTTP packet or not, it is displaying everything. What if I put here DNS? See, so what will happen here is I have the DNS packets. Okay, and I have packets of this IP as well. And here I'm using OR condition. In the middle, I'm using OR condition. So Wireshark first will display the packets of this IP. Okay. Yeah, Wireshark will display me the packets of this IP address. Like every packet, protocol of like packet of any protocol, whether it is a DNS or not. First. Secondly, it will also show me the DNS packet, whether there's a involvement of this IP or not. So we are using a OR here. So OR here is like no matter if one, here you can see this filter is not affecting this another filter. So they are like acting individually. They are acting individually. So here you can notice we have the packet of this IP and every packet. It doesn't matter it is a DNS packet or not. And we have the DNS packets no matter if we have the packet of this IP or any other IP. So we are using OR here. So that is a kind of you can combine multiple filters. That is a kind of important here. Okay. Same as we can use operators like greater than, less than. Okay. For example, here we have this response port. Let's say, let's capture the packets. Okay. Let's restart the capture. And here I'm visiting this website. I'm refreshing this website. Okay. And I'm refreshing this website as well. So we have some packets here of HTTP. Let me change the machine. And one more thing, the interface of the Linux, like how you operate the Wireshark in the Linux and how you operate the Wireshark in the Windows are similar. They're like same. There's no difference. Even there's no 1% of difference between the interface of Wireshark in the Windows and interface of Wireshark in the Linux. So let me show you here. My machine is not working. So this is file, and in this file I have around 47,000 packets. Okay, 47,000 packets. Now here I wanted to see the HTTP packets. Okay, we have this HTTP packets. Okay, now what I can do, I can let's say I just wanted to see the web pages which have loaded successfully. So I can use the response code here. Okay, we have this HTTP response code. Let me show you. Okay, like what if the response code is 200, 404, 500, and so on. So 200, okay, and these are HTTP response code. So let's say if I use http.response code is greater than 200. So I will see the packets where the HTTP response code is more than 200. 200 is not included here. So you can see two web pages are there, two packets are there which have the response code 404 and 302. So what I mean is we can use a this comparison operator as well. Here I can use less than. So this will show me less than 200, which I don't have. We can use equal sign, equal 200. So we have two packets here. We can use these operators. This one. This is greater than, less than, greater than, equal to, less than, equal to, not equal, double equal. If I wanted to see this filter, so this filter will show me the packets which have the response code more than 200 and 200 is included here. Why? Because I'm using equal sign here. 200 is included here. If I remove this equal sign, so 200 is excluded. It is not included. So we can also use comparison operators. If you wanted to see the Wireshark default filters, so here we can see from the analyze, there's the option of display filters. These are Wireshark default filters. Again, we can add our own filter from here. We can click on plus. You can write filter name, that's important filter. And here I can mention any filter name here. Okay, like for example, I can mention the website name, Amazon.com, or any filter you can add. So now you can see we have important filter. You can remove filter, you can add filters. So these are like some default filters of Wireshark. Again, they follow the same mechanism. Okay, like equal sign, and operator, or operator, greater than, less than. You can also apply the filter on the basis of MAC addresses, IPv6, IPv4. Even you can see this filter. If I show you this filter. So this filter is saying that I just don't want you to see the packets of DNS, whether it is working on UDP or TCP. That is not sign. So you can also use not sign here. This is known as not sign here. Okay, let's say I just don't want you to see the TCP packet. So I can use not TCP, like this sign in TCP. So how many packets are there? Remaining 45,000. Means 2,000 around packets are of TCP. So these are the packets which do not include TCP packets. These are like all UDP packets or some other packets, but not TCP packets. So this is a kind of a not here. Same as you can use any kind of filter. I will provide a cheat sheet for the capture filter and for the display filter so that you can all apply and you can like use it. So last thing is we can also bookmark filters. For example, I want to bookmark this filter. So I can tick on this blue option and I can bookmark, save this filter. So now if I wanted to use this again, see, there's a filter here. I can name this filter not TCP. Okay. Now you can see yellow sign here. If I click on here, you will see not TCP. This is added here. Same as we can add this filter as a button. This one you can click on this plus option, plus. Now you can name your filter. Name of my filter is not underscore TCP and click on OK. Okay, now you can see this button has been added here, not TCP. The same you have to apply in the Windows. Okay, same mechanism. If I remove this filter, see, if I remove this, and if I tick on this not TCP, see, the filter has been applied. Okay, so we can apply filter as a button and we can bookmark any filter. This is one way of applying filters. Okay, this is all just we have discussion. We have this all discussion. This is one way of applying display filters. For the capture filters, we can just create our own filters by following this syntax. And we can take filters from the cheat sheet or we can take filters from the internet. For the capture, for the display filter, we can either create our own filter. Okay, first is we can create our own filters. while following the syntax. Second is, we can also take filters from internet, or we can say cheat sheet, or we can Google it. Okay, like we can Google it. So we can Google it. Third option is, we can add filters from the packet details. Okay, like here we have this packet details. So we can add filters from here as well. So that we will see in the next session, like how we can add filters from the packet details. So third option is, this is only with the display filters, not with the capture filters. So we can add display filters from the packet details. And last option is, we can add conversation filters. So we have covered two filters, like you can take from the cheat sheet or from the internet, or you can create our own filters. The rest we will see in the next session, like how we can add filters from the uh, details and how we can add conversation filters. Okay, that we will discuss in the next session. Any questions up to here?
No questions.
Yes, ma'am.
So let's summarize. So what we have discussed today, we have discussed the interface of Wireshark, how we can get familiar, what are the components of Wireshark, how we can operate Wireshark, how we can install it. And then that's some theoretical part, which is not that much important of the Wireshark, like the checklist and so on. Okay, then we have discussed about the name resolution, which is again very important, the display filters and the capture filters. From the display filters, two parts are left, which is these last two parts, which we have to discuss in the next session. Okay, and then, yeah. So this is what we have discussed. Okay, so any other question? Like, is there anything anyone wanted to clear apart from this discussion? Okay,
Ma'am,
so
it is
rest.
hello.
Yeah.
If I filter it, suppose that we are sitting in fifth floor, and sometime we are facing a network slowness in first floor. They are saying that we are slowness of network. How we are filtering that?
Like you wanted to identify the latency, right, in the network?
Yes. They are using only one software to to enter the details of product, and the server is in third floor. So where I am capture the data.
You can capture between your machine, your client, and your server.
Client and server. Can I?
Yeah.
Okay, I
You
understand.
can
It is possible to on my machine to capture the data of
of the server.
server and client both.
See, what you can do, if you wanted to capture the communication between your client, your machine, and server, then you can apply the filter of the IP capture filter of the server. Then you can ping
Yes.
your server from your machine, and then you can capture some XMP traffic. If we have some latency, then you will able to identify that in the Wireshark. Okay, that we will discuss later. And if you wanted to capture the packet of remote machine, which is remote server, then you can also capture from your own machine with the help of T-Sharp. That also we will discuss later. Okay, so that you can do both.
Okay, ma'am.
Okay, so in the next session, we will discuss T-Sharp only. So that then we will see.
Okay, ma'am. Thank you.
Okay. So thank you everyone, and let's discuss the rest part in the next session.
Thank you.
Thank you.